Test D, the other circular equation, y equals kx. It's much easier. And this is a line with gradient k going through the origin, and it must cut this circle at two distinct points. So it can't be a tangent, and it's got to hit the circle. So minus 3, 5 is up there somewhere on relative to my axes, and the radius is 5, 2. And look, y minus 5? Minus 5 is down here. No, y plus 5. There. Yeah, change the sign, remember. Minus 3 plus 5 is the center. So minus 3, 5 is the center. The radius is 5, which means it goes through that point there. And there's my circle, touching the x-axis. And I've got a point here that I'm going to have lots of different lines with gradient k coming from. So from my graph, I can see that one of my y values I want, this gradient is nothing, so y equals 0, k is equal to, therefore k is equal to 0 is one of my tangents. I just want to find this one over there. Okay, and to do that, I'm going to find the 0 value as well at the same time, because what I'm going to do is substitute this y and put the kx in there, and then square the bracket, and I've got a quad in x then with some k's in it. Let's see what we get. X plus 3 all squared is x squared plus 6x plus 9, plus this one squared, which is k squared x squared. Take away 5 times kx doubled, which is take away 10 kx's. 5 squared is 25. Take away this 25 is equal to nothing, so those two go away. And I've got an x squared in these two terms up, so I've got x squared times k squared, that one, plus the one of them. I've got an x term, so I've used those up. I've got this x term and I've got that x term, so I've got 6 minus 10k. So I've got those two in my simplified expression. I've got add 9 equals 0. Okay, so this is what I call the solution equation. Find the range of values for k. The range of values. So I wasn't thinking about the question properly earlier. This is going to be a limit. K equals 0 is a limit, isn't it? And I'm going to turn that line round 0, getting less and less. So start at 0. I'm going to get negative, 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 negative. And I'm going to get vertical. So that's k is, I don't know, infinite or minus infinity, I'm not sure, because that's 0. This is bigger and bigger and bigger, negative, and then I get plus infinity, and I get round to this one, reduce it from plus infinity all the way down to whatever that positive value there is of the gradient of that line here. Okay, so I want all those values. I want okay, so that's my solution equation. Because the straight line hits my curve twice, the discriminant of this quadratic equation has got to be bigger than 0. Alright? To find the discriminant of the quadratic is going to be equal to 0 in the first place. And the discriminant is b squared, take away 4 times a times c. This is a, that's c, and this is b. So that means that 6 minus 10 k all squared. Take away 4 times a times c. Well, I'm going to do 4 times c, which is 36, times k squared plus 1, which is my a. And that must be bigger than 0. So look, I'm going to get quadratic inequality, which we've been practicing. Right, 6 squared. Well, I don't like that way. 6 minus 10 k when we square it is the same as 10k minus 6 when we square it, and I like it this way round. 10k squared is 100k squareds. Take away 6 tens doubled is 120k's, and take away 6 squared is plus 36. Take away 36k squared. Take away 36 is bigger than 0, and oh look, this is really 36 k squared. So this is really simple. It's just a two-term quad. I've got 64k squareds. Take away 120k's is bigger than 0. So both of these terms divide by 8 to give me 8k squared. Take away 15k is bigger than 0. This factorizes k bracket 8 minus 8k minus 15. If that was equal to 0 and we were doing our 5-step process and solving the quadratic equals 0 first, I've got k is 0, this one, and k is 15 over 8. So 0 and 15 over 8. It's a positive k squared graph. We haven't played around with it anywhere. It was always positive. And I want where that's bigger than 0. So what we're doing on this graph is k on that axis, not x. And I've got discriminant on this axis, not y. And I want discriminants bigger than 0, which replaces this one bigger than 0. And when I'm thinking about my quad. So there's my furry graph. So I want k this side of nothing, I want k that side of 15 over 8. So look, there's nothing, put k this side of it. There's 15 over 8, put k that side of it, and the arrows point to small numbers. And there's my range of values. So I want k is less than 0, and k is bigger than 15 over 8, which is 1 7/8, which is 1.875. Fantastic.